Today we shall see about refraction through spherical lenses. So initially, where do we use spherical lenses? In our day-to-day life, we use spectacles for reading, and watchmakers use lenses to magnify the smaller parts, and also in magnifying glasses. And there are many more utilities for spherical lenses in our day-to-day lives. So basically, what is a lens? A lens is a transparent material which is bound by two surfaces. Okay, so transparent in the sense you can see through the other side. So a lens is a transparent material which is bound by two surfaces. So among these two surfaces, both can be spherical or any one can be spherical. So that is what the definition means. It is a transparent material bound by two surfaces of which one or both surfaces are spherical. It is not mandatory that both the surfaces should be spherical. Okay, so this is a basic hierarchy of how the lenses are divided. So a lens, basically it is divided as convex and concave. And this convex, it is divided as biconvex and plano-convex, and concave as biconcave and plano-concave. So in this, if you see bi or double, that means it has got two surfaces. That is, both the surface of the lens are also spherical. Both the surfaces are spherical. So that means the biconvex lens. And plano-convex is, one is a plane side, like a plane mirror, like a plane side. I don't mean a mirror, it is just a plane side, and the other is a spherical lens. So that is where the name is coined as plano-convex lens. The same thing is applicable for a concave lens also. So now we shall see each lens in detail. So the first one is convex. The convex, basically it is the biconvex or double convex. It is generally termed as a convex mirror. When you tell it as a convex mirror, it eventually means it is biconvex mirror. Okay, so this convex mirror has got two spherical convex surfaces. See, this is one convex surface and this is the other convex surface. So it has got two spherical convex surfaces, both are combined together, and the major property is it is bulged at the center and it is thinner at the edges. So this is the other types of mirrors which I told you, which we saw in the previous slide. It is a biconvex. It has got two convex or two spherical lenses combined together, and this is one is the plano-convex. Then the next, the same thing, it is concave or biconcave or double concave. When I generally mean a concave lens, or in your problems when it is mentioned as concave lens, it means it is a biconcave lens. So as like your convex lens, this concave lens has also got two spherical concave surfaces. So if you see here, see this, it is one concave surface and this is the other concave surface. Both the surfaces are combined together, and the property is it is thinner at the center and it is thicker at the edges. And this, it is the other type of the concave lenses. This is the plano, this is the plane side, and this is the concave side. So it is termed as plano-concave, and this is biconcave. Bi means two, so that means this is the first concave side and this is the other second concave side. So if you notice, there is a highlighted word here. It is called as a diverging lens. A concave lens is called as a diverging lens, and a convex lens is called as a converging lens. See, converging lens. We shall see about all this in depth in the future slides. Just as of now, you remember that convex, it is a converging lens, and concave, it is a diverging lens. Even for simple understanding, you can easily remember convex. Most of the words from the word convex till E comes under converging till E. So you can easily correlate that convex lens is a converging lens. Similarly, a concave lens is a diverging lens. The next one is, we shall see about the terminologies which are used in the lenses and all the problems altogether. So you know already about centers of curvature, principal axis, optical center, that is a new one for you for lens, aperture and principal focus. So we shall see in a proper diagrammatic way how these things are represented. So first we'll see for a convex lens. Convex lens, you know that it has got a thicker center and a thinner edges. So I have drawn a convex lens. So this, you know that this is the principal axis. Okay. So here, so principal axis, it is the line which is center line which is passing through the entire length imaginary line. And at the center of the lens, you have something called as optic center. Usually you have known about poles. Okay. Instead of poles, what we have got here is the optic center, which is the center of the lens. So now imagine this as the first side. The thing I am shading here lightly, this as the first side of a convex. So this, if I extend, this will be extended like a circle here. You can extend it over like a circle. Similarly, this unshaded side also I can extend it to the other side. Now, if you consider the first circle, this circle obviously has got a center, right? So this, usually we call it as center of curvature. Here, since we have got two circles, we are just naming it as C1, center of curvature of the first circle. Similarly, here I have the center of curvature of the second circle, C2. And if I get a focus over here, I have a principal focus. So this also I term it as F1, and similarly here I term it as F2. Since there are two sides, two circles, I am just giving the names as C1, F1 and C2 and F2. And the new thing for you is the optic center, which is the center of the lens. So under this C1, since it is the curvature, you know that radius, that is the distance from the optic center till the center of curvature, this is the radius. This radius R will be equal to, you know the formula from already. So you know the formula from the mirrors that radius is twice the focal length. So similarly, this C1 I can also call it as 2F1, and this C2 I can also call it as 2F2. Hope you understood. This is the diagram or the terminology representation for a convex lens. And convex, since most of the term comes under converging. From this word, you can easily term that it is converging. Most of the words come from this itself. So convex lens is a converging lens. So similarly, I have drawn a concave lens now. This is the first concave side and this is the second concave side. So if I extend this, I get a circle over like this. Similarly, if I extend this, I get another circle here. So this again will be my principal focus, and for this particular circle I have a center of curvature C1, and this circle I have center of curvature C2. Similarly, this will have a focus, I term it as F2, and this will have a focus, I term it as F1. You can name it either way. I can even take F1 C1 here and F2 C2 here, that depends. And the same way C2 I can also call it as 2F2, and C1 I can also call it as 2F1. This is the basic terminologies of a concave lens. So as you have seen that concave lens is a diverging lens. Now getting back to the actual definitions. Remember the diagram and then relate to the definitions. You can easily understand. So the principal axis, each of the two spheres of the spherical lens is a section of a sphere. Each of the sections of the spherical lens, see here, this is one section and that is a part of the entire sphere. Similarly, this part over here, this belongs to this sphere. So the line passing through the two centers of curvature of the lens is called as the principal axis. So this line which is passing through the two centers of curvature of the lens is called as the principal axis. Next one is the optic center. The point of the principal axis at the center of the lens is called as the optic center. So this point at the center of the principal, or the point at the principal axis, which is actually at the center of the lens. So this is the lens, this part alone. So this is the center of the lens. So that is called as the optic center. Next one is principal focus. The light rays traveling parallel to the principal axis after refraction meet at a point on the principal axis. So this, when the light rays are traveling from one side, after converging, you saw that convex is a converging lens. So after converging, they meet, all the light rays meet at one particular point on the principal axis. So this point is called as the principal focus. And you already know that the distance between the optic center and the principal focus is the focal length. The distance between the optic center and the principal focus is the focal length. Okay. Then the last one is the aperture, the effective diameter of the circular outline. Diameter is nothing but this vertical height. It is called as the diameter of the circular outline of the lens, which is also called as the aperture. So now coming back to the convex lens again, I'm just summarizing it. Just consider the convex lens, and these are the terminologies. We have the principal axis over here, and we have the optical center of the lens, which is the center point of the lens, and we have two center of curvature, C1 and C2, also called as F2, 2F2 and 2F1, because of the formula radius of curvature is equal to 2F, and we have the principal focus. In the similar manner, we can say about a concave lens. See how a concave lens is formed. It is again a combination of two spheres, and we are taking out the spheres separately, and we have the principal axis over here, and we have the optic center, and we have C1, F1 and C2 and F2, and we have the focal length. Okay, so now next to the activity, which is 10.11, to determine the focal length of a convex lens. This you can actually do it and see with, if you have a magnifying glass, just focus it towards the sunlight and let the sunlight fall on the magnifying glass. On the other side, instead of a screen, you can have a white paper. So when you have the magnifying glass focused at one single point for quite some time, you can see the paper begins to start burning and to produce smoke. Okay, so what happens here is the rays are converged. Since the sunlight, which is what we are getting, we consider it as parallel rays. When it is concentrated or converged by using a magnifying glass, which is a convex lens, and the point at which you get the bright spot on the paper, that it is actually the real and the inverted image of actual sun. You are capturing the image of sun there. So since all the light is focused at one point, the distance between the paper and the magnifying glass will tell you the actual focal length of that particular magnifying glass. So now we shall see in detail how the refraction actually happens in both the lenses. Consider first the convex lens. So imagine the blue lines are the parallel rays from the sunlight, and since it is a converging lens, since it is converging or concentrating everything, it concentrates and it just produces a focus on the other side of the lens. So this is the principal focus, and that is called as the focal point, and the distance between the optic center and the focus will give you the focal length. So this is the general definition of a convex lens. Similarly, getting back to the concave lens, see here. So as per the definition, see, since it is a diverging lens, diverging is what? It just spreads away, it spreads out. So since if you see the red color rays, it is there, after refraction it is actually spreading out. It doesn't meet. So what actually happens here? We actually extend or extrapolate the lines and make them to meet at the principal focus. So this is where you get the image, and since you are extending it, it is also called as it appear to diverge from this point. If you look closely, if you just take it from here, you can extend it and you can think that from this point the light is actually getting diverged. So that is the reason you get the principal focus here, and the distance between this principal focus and the optic center will give you the focal length. So how to determine the focal length of a convex lens? It is a very simple diagram again. So from this is the basic how you determine optic center F1, and I have 2F1, otherwise the center of curvature C1, F2 and C2. So from this, the parallel rays, everything converges after refraction. It just converges at this one single point, and this is the focal length. The parallel rays after refraction from the lens converge to a point on the principal axis. This point is the principal focus of the convex lens. So the distance between the principal focus and the optic center is called as the focal length of the convex lens. Similarly, for a concave lens again, this is a little trickier part. the parallel rays actually diverge. If you see the blue color rays and the arrow marks properly, they actually diverge. They do not meet, but we extend or extrapolate it, and we make those are represented with the dotted lines over there. So we extrapolate it and we make them meet at one point on the focus. Okay, so the parallel rays after refraction appear to diverge from a point. This is appear to diverge from this point. If you notice, from this point it happens that these rays are diverging. So that is the word there, appear to diverge from a point on the principal axis. This point is the principal focus of the concave lens. The distance between the principal focus and the optic center is called as the focal length of the concave lens. Hope you understood the topic. If you have any doubts, please get back to me. Thank you.